Hello everybody and welcome to Vienna and our MOOC today on Orchestrated Service Virtualization. I'm afraid it's a bit of a mouthful. With us today we have myself and I am Tony Leeming. I am a Tricentis training consultant, and we also have Alexander Moore, who is our official title is... what is your official title? Evangelist, excuse me. And he is our expert on orchestrated service virtualization, and we're very privileged and very lucky to have him. He's a very busy man, and he is an absolute guru when it comes to this information and the topic that we'll be talking about. So, let's talk about what that topic briefly is. But first of all, let us talk about the topic. Go back a slide, excuse me. We'll be talking about creating virtualization scenarios. We'll be looking at using the API scan for testing OSV, Orchestrated Service Virtualization, or of course, enabling automated tests, which are simulated or third party. Okay, so briefly, let's quickly run through a little bit of the MOOC etiquette. I know, and I apologize to those of you who are our regular viewers, that you're hearing this again and again and again. However, we do have more new people every day. So we've started on time and we'll finish on time. We've had to mute your computers because there are around 500 of you on this call, and if you all ask questions at the same time, it will be a bit loud. So you can ask questions in the question box, which you can access using the apps which are at the bottom of your screen on our nice new and improved webinar format. So you've got a series of boxes at the start of the screen, and you should be able to click on the question and answer box and ask questions, and we will answer them live when we can. We'll do our case to answer them live in the question box, as long as they're on topic, but the good ones we will save for the end of the session that we will answer, and Alexander will answer as a group for everybody. Please do keep the questions on topic though. We can only answer the questions that are relevant to the topic itself. We're recording the MOOC and it's available to view on our website, academy@tricentis.com. As you said, we've got new MOOC technology. This new MOOC technology should give you a more interactive version and your more interactive method of working. One thing please don't go to the media player and close it. If you close the media player, you switch us off and we won't be able to hear us, which of course we don't want at all. Okay, so as we've now covered through this, I'd like to introduce Alexander to you, and he will now start and looking at Orchestrated Service Virtualization. Thank you very much.
Thank you, Anthony, for the introduction, and welcome to our first MOOC, most massive open online course on Orchestrated Service Virtualization. My name is Alexander Moore. I'm evangelist and part of the product management group at Tricentis, and really happy to have you here and to go into detail about Orchestrated Service Virtualization. The MOOC is supposed to be more a technical session, so we will focus on a demo, but however, we want to show you and want to explain you briefly why do we need service virtualization and what is the best use case for that. And let me explain you here, or let me start here with the typical current situation that we see at the customer side and what the pain points are. And these pain points we typically divide into two different streams. The first depends on how you are currently working, how are you testing. We see on the one side agile teams, and on the other side, when you're already transformed some of your projects or some of your applications into more an agile technology or more into agile paradigm, or let's say the waterfall approach testing in test environments. So if you're working in agile teams, typically you have set up an agile team. Developers, testers are supposed to cooperate and are supposed to test immediately. The idea here in those agile teams is to have an immediate quality feedback and not as it was, let's say, in the waterfall time where development has been done 3 months and then later, 2-3 months later, perhaps testing has started. The idea of those agile teams typically, and this is what we see, is a continuous integration or an immediate quality feedback. So how does continuous integration work? The idea here behind is that developers they are starting the work, they're creating a user story of requirement, and once they have finished the work, they will check in their code into a versioning system. VCS, this is the abbreviation here for versioning system. This could be an ISO-N, this could be GitHub or anything else. Based on the versioning system, a continuous integration server as Jenkins would trigger a compilation and would trigger test executions. Typically, when you speak to developers, they focus here on unit tests. Unit tests are good, unit tests are necessary, and we see that more and more for new developments, unit tests are created. But always keep in mind, in an enterprise environment, unit tests are not sufficient for a full quality feedback. Yes, it's right, you get an quality feedback, you get an immediate quality feedback, but unit tests typically cover 20–30% of a system business risk. So what you need is, you need also to include system and system integration tests. And this is where the HR teams have the challenge: how can we execute those tests? And then it comes to, how is the typical manual staging process set up? The typical manual test or the manual staging process, which is a bit of waterfall process, is that the development in enterprises is done decoupled. Some of those teams are already agile. They already would like to deliver and test every day or every week or every day or every 2 weeks at the end of the sprint. But they still need an integration environment for comprehensive tests. So what's typically happens in those environments and in the enterprise environment is there are still a test center of excellence. There are test managers who coordinate the test start. Release management coordinates which version of which applications can be deployed to those integration environments and when can those tests start. Typically, we see customers here co-working with 1 month or 2 months or sometimes already faster deployment cycle. That means that the systems are deployed to those integration environments every 2 weeks, every 4 weeks, or sometimes still every 2 months. What happens now to those HR teams? They are not able here to have a full and immediate quality feedback. And also the testing for those who are not that agile, let's say, still is very cumbersome. What is the problem in those test and staging environments? Ask yourself, what happens if one of those components are not available, unstable or delayed? Your test is blocked, you cannot execute your tests. How much effort do you have to prepare or search for test data in those test environments? How do you handle cloud-based or expensive third-party services? And do you have multiple vendors, perhaps nearshore, perhaps offshore, that you have to cooperate? And now imagine or think about how many systems do you typically need in one of your full end-to-end test cases. We see here that typically 20, 30, up to 33 systems are required for a full end-to-end test case. And if one of those systems are not there, you can't do your tests. And this is where service virtualization comes in place. What is the idea of service virtualization? And this is what we will also show in the demonstration. The idea of service virtualization is that we simulate service calls. So we look, or we focus on a system and a test. We will here focus on insurance demo application, and we understand that this system and a test requires data from third-party system. Here in our demonstration, we have an insurance app. An insurance app will require data from a CM or from a rating system. So the idea of test-driven service utilization here is now to focus first on the tests. Tosca executes UI, API tests, or even tests via a file or a batch run. And orchestrated service virtualization, placed as a man in the middle in your test environment, can record the services which are exchanged between the system and the test and the third-party system during test execution. These service requests, like get a customer and then send back the customer data, can be recorded, or they can be built from scratch. Scratch means you can use a definition file like a WSDL, a Swagger file, a WADL file, or also some example files, could be XML file or JSON files, for example. Once you have created the service virtualization, you will switch OSV in a simulation mode. And OSV, Orchestrated Service Virtualization, simulates all surrounding systems for test execution. It does not only simulate, it also analyze and verify. Verify, why is that important? Let me give you an example. You will enter data in, let's say, in an online shop, and you enter all the customer and product and all those settings, and when you press the submit button, you typically, as a tester, would now switch to an order processing backend system to check if all the data has been handed over in a correct way. Here, OSV verifies already at the interface level, making sure that the data handover has been correct, so you do not need to have the third-party system available or test in those, or check, verify the data in those third-party systems. Service virtualization includes functions. Why is that necessary? You want to make sure that when you use a sysdate or a birth date, that the person is always 19 years, 65, 50 years old. You can use data from the request and respond it, give it back in the response. You can use substrings, mathematical functions, anything you want to use here for a dynamic service virtualization. This is also the benefit when you compare it to stubbing. Service virtualization is an intelligent stubbing. It's not just intelligent stubbing, you can also combine it with variance and test data. And service virtualization provides here the possibility of a team-oriented setup. Team-oriented setup means enterprise-wide, once a service virtualization has been created, you can reuse it in your full enterprise. We do not only speaking about services, it's not only about a request and response. Typically, test cases do have stateful, or let's say more complex scenarios. What is a complex scenario? Let me give you an example. Every test case that creates, modifies, changes, or deletes data is here a more complex, or what we call stateful business process. One example, you will create a new order, then you load the order ID, and once you have loaded, then you will check if the data is there, and then you set the change the state, for example, from active to decline. Again, your system on a test will reload the data after it has set the new state, and now it will get a different response. What we see here is based on the state, based on where we are in our process, the same request, give me the data for this order, 1, 2, 3, for example, you get a different response. And this is what we call a stateful business process. When you use service virtualization, the big advantage is that these changes, these modifications are simulated. You do not need to recreate the test data every time you run your test case. Speaking about test data, service virtualization provides test data management at interface level. We provide here in Tosca, Tricentis, a combined test data repository for service virtualization, for API tests, and for UI tests. The big advantage is here that you have always consistent test data when you execute your tests and when you simulate third-party systems. We see here the approach on the market to have, when you use two different tools, that you have two different data repositories that you, at the second step, need to maintain and keep consistent, which is which takes a lot of effort, and which also provides, or which could also lead to a lot of false positives or negatives, because just the test data is not consistent. We also provide, and Anthony already said we will show you the API scan. We provide what we call an API scan. We know that when it comes to API tests and service virtualization, the technical skills are often with developers. So what we want to provide here in the HR teams is we want to pick up all the assets that are typically created early in the life cycle from the developer and reuse them for QA. The developer can use the API scan, create API test cases, and hand it over to QA. QA test, those are the guys who are familiar with how to set up a smoke test, a regression portfolio to test the boundaries, thresholds. They have the testing knowledge. They set up the full regression portfolio, combine it hopefully in a continuous integration, a CI, and let it then execute every night or every time your developer checks in. Once a defect is found, the QA can identify the defect, export those artifacts, send it back to developers. Why? Because we avoid media breaks. We can reuse all those artifacts and may have a smooth interaction between developers and QA. And also for those non-technical guys, for the business analysts, or for some of those testers who are not that technical, we provide here a more user-readable, friendly UI for API tests. Of course, I will show you that now in a demonstration. So let's switch to the demonstration. What we have prepared is we have here our insurance application, the Tricentis vehicle insurance application. In this insurance application, will retrieve data on the first page from a car configuration system via a web service code. On the second page, When we enter customer data, a service call is triggered to the CM system to retrieve the customer data. And when we press the next button, the customer data will be saved to a CM system. On the third page, a rating is executed. The rating is executed based on the customer data. And after filling in all the other data, like a price option and quote information and email and things like this, we will send the data via a web service request to an order engine. And then we will switch back to the order engine and view the order, and we can also change the state from created to cancelled, for example. What we will do also is, or what we have done already, is we will configure orchestrated service virtualization as a man in the middle. What does that mean? That means that the service requests are sent from the system on a test to OSV, to orchestrated service virtualization, and orchestrated service virtualization will forward those requests to the real system. So, time for the live demo. Let me switch here my monitor and show you how OSV can be set up and how it can be used. So, first step. You can see here our application. On the left side, you see the browser, our vehicle insurance application. On the right side, what you can see here is a black console window. These are the third-party services where the car, the CRM, the rating, and the other services are running. Typically, this would be, of course, in a real environment on a server. Here in my demo environments, it's on the same machine. So, first step, let's assume you start testing in the morning. Let's see if the system is working. And let me make a check here if we can start testing or if we get an error message. So, on the first page here, when I choose BMW or Volkswagen, you can see here in the console that there is a logging done. So, my backend services here logs every request, so I can see what's happening in the background. This is here. Let me here show you how this typically works. Our application here will trigger web service requests to the real services. The real services here, the car, the rating, CM, and other services, they are here on my same machine. So this is the endpoint where this localhost 8888, and then the resource identifier, sample car service, sample CM service, and so on. As a first step, what we need to do, we need to create in OSV our service ports. So based on each of those services, we will create the service ports. How does that work? In OSV, this is what you can see here, the client monitor. OSV itself is installed as a service. That means once you have installed it, it's running as a service, so it can then listen to any request from your system on a test. The first step we need to create an environment. What is an environment in OSV? An environment is a logical grouping for your test activities. You can group different applications, you can group versioning, you can group several systems, test environments. However you want to set up your testing, the environments here are the logical grouping. Project, test data, versioning, different versions, different staging environments. First step, I need to create my environment. So I will call my environment here now my first test environment. And I need to define a database. Database, why? Because all the service virtualizations we typically use in our for simulation here are stored in a database. Typically, I guess in your environment you would use an SQL server, or Oracle, or DB2. In my example, I will now use a SQLite, which is just a file database stored here on my machine, and create those database. The first thing I need to do is here create a database, and once this is done, my environment will be created. What you can see here in the end is proxy. We can also provide, or OSV also provides a proxy server, which is a second possibility of configuring the services. I will explain that in a second, but we will not use it now. Of course, you're free to use the proxy then later in your environment. So what I have here done, I have now created my first environment. Here I can start the environment and I can create so-called service ports. What are service ports? Let me here switch back to the view that you have seen. What we need to do is we need to create for each service a service port. Where do you get this information? Typically, you will have a list of, for each application, which services it uses. This is a one-time task that you have to, let's say, coordinate, align with operations or with your developers to get those information. Typically, those systems have something like a configuration file, a configuration database where you can change and where you can see those services. Here I have what is called an endpoint file, and in this endpoint file, all these different services are stored. So what I do is I will now configure my first service. In the endpoint file, I can see here sample car service. This is the endpoint HTTP localhost 888 sample car service. So in OSV, I will create the first service port now. I can call this, for example, car service. This is the name. You choose the type, which is HTTP in our example, and I choose the format. Both is XML, request and response. As we have a real service, we want to forward also a request to the real service. We have here the possibility to activate real service forward. The port is the technical port based on TCP/IP. You can choose here any port that is free. I will, for my example, now choose 62,000. And I need to define the real service, the forward. So I here copy, paste the data from before. I tell OSV that this is a SOAP service, and this is already my first step. Sorry, this is already my first step here to create a service port. So I have applied the change, and I can see here now car service. My first service is created. It's an HTTP type. It's XML. It listens on the port 62,000, and it would forward each request to the real service. What is forwarding? Forwarding means that if OSV, if Orchestrated Service Virtualization does not know or has not a service virtualization for the specific request, it will forward the request to the real system. In my configuration file, I would now change here the port number, and that's it for the first service. The same step has to be then done for all the other services. You can also automate it, or you can upload it, or there are some steps. If you have not 4 or 5 services, but 50 or 100 services, there are also some, let's say, steps to make it more comfortable. Here I have now changed one service. I have already, of course, done exactly what we need here for my system under test. So I have already configured not just one service, but all the service ports, which are the exact steps as before. And I have changed our configuration, our endpoint file, so that each service will send the service request, my system under test send the service request to OSV, and OSV will forward it to the real service. How does that look like? It looks like that, where I have now my system under test sends the request to OSV to specific ports, and OSV, Orchestrated Service Virtualization, configured as a man in the middle, will forward this request to the real services. This is an operational, or let's say a configuration task, which has to be done one time, only one time, because from then on you can simply use also the real systems. You can use the system under test, and you can use service virtualization. You can OSV here decide if the real system still should be triggered. The second possibility is to use a proxy server. We will not go into detail here now. The proxy server is a second possibility of configuration. You can set a proxy server on your system under test, so that an OSV will act as a proxy, meaning that you do not need to reconfigure each service individually. Based on your system configuration and on your requirements from operations or from development, both configuration types are valid, and you can then choose or align here these operations. So this is the first part. This is the configuration part. So I have done already. I've solved the configuration part. Let's now move on with our service virtualization. What happens typically when the backend system is not available? I will here in the background shut down my backend service. So I simulate that again. I think you know this. from your testing area, one of the systems are not available. So what happens if I choose, for example, Volkswagen or BMW, I get an error message. In fact, I'm glad that I get an error message. So I know immediately that my third-party systems are not there and my testing is blocked. So this is the point where OSV now can help. Let me restart my backend service and let me show you how service virtualization supports you. First step is I have reconfigured already my services. So all the service requests are triggered, are sent to OSV, and OSV forwards them to real services. This is how OSV can simply record all the traffic that is exchanged between the system and the test and the backend service. Here in my area, I will now switch to the recorder area and start the recording. Enter, for example, Max Mustermann. We know that we have some data here available. And my backend service, I can see that here on the console has been triggered. Also, in OSV, I can see here in the recording area that now those two requests, the request and the response has been recorded. I can here show, I can view the message detail. The in message is here the Max Mustermann, and the aus message here is the data that the CRM has sent to my system on a test. So I have recorded those request response, we call it RR or request response pair, and I can transform those two messages simply in a state, in a virtualization, in a service virtualization. Therefore, we have the menu or the function deploy request response pair as scenario. I choose a name like Max Mustermann, and in the available area, this is here the area where you have the different functions. You can see here the environments, the available or the recording area. I will also show you then during the demo the separate areas. I have now my first scenario available. That means I can shut down my backend system. I can refresh the application and enter Max Mustermann, and I can do my first test case. But this test case still only relies on one record, on Max Mustermann, the one we have recorded. I said before we can provide a test data repository, what is in Tosca language a test case design. So how can we use now the test case design, and how can we make use of the recorded message in Tosca? In Tosca, I have already created a test case design. The test case design here has 3 columns. There is one configuration task that we will not walk through now in detail. When you use service virtualization or your repository, you will import some project definitions for service virtualization, and you will configure the service environment. The service environment is an additional property which can be configured on any kind of component folder, like here the OSV environment, OSV host. Here it's empty. Why? Because it gets this data from the root folder. You can, of course, always change those settings on each component folder. So, speaking about the test case design, what I want to do is, as a first step, I want to import the recorded messages and make reuse of those service virtualization messages now in Tosca. So, therefore, I have a function which is called import single scenarios. I'm asked if I want to delete the messages from the host. I say no, perhaps I will still need them. And now Tosca has created the modules and the scenario for me. The modules follows the same principle as the UI modules. So I have here the modules for the request and one module for the response. And the scenarios. The scenarios here are here defined in the same way as a test case. I have a request and a response. What is different is I have for each virtualization scenario one direction, one transport, one payload. Direction in out, you always can change the direction here. So I could change here the direction from out to in, for example, to change the principle. I could make an asynchronous call where you have one in, 2 out calls, or I can change here always change the direction according to what you need in your virtualization. The transport, I can change the transport also by using implement specialization. For example, I can here change it to GMS receive. That means I would use, in this case, I would connect to an enterprise service bus. And the payload. The payload is the technical XML or JSON file, for example, and shows me here now the static data that we have recorded. Still, this is static. How can we now combine those static scenarios with our test case design? The principle is exact the same as it's used for typical test cases in Tosca. So, as a first step, I need to delete the data, what I will do here. And here I'm just on the root node. And as a second step, I will then convert this scenario into a template, which is the same principle as for UI test case. Once I've converted to a test case, I can now combine the test datasheet with the scenario. Doing that, all the fields are here automatically populated. Why? Because I have already set up the test case sheet in a way that the fields are matching with the scenario. And as a last step, I will now create the instances and deploy those instances now back to OSV. In OSV, in Orchestrated Service Virtualization, we have now 4 scenarios enabled. One scenario is still the MOOC Mustermann from before, where we have transformed the recording as a static service virtualization. And the other 3 examples we created by combining a recording and combining it with our with the test case design. That means in the application, I can now here not only use MOOC Mustermann, but I can also use, for example, let me here open the test data sheet so that we can see in parallel which data we can use. I can, for example, use John Wild, and John Wild will now be processed by Orchestrated Service Virtualization. You can also use the Maria Snow or the other one. You can see here the date of birth that I'm using here already a function, so I can make sure that this person is always 19 years old or 65 years old, like the John Wild, which should be a person with 65 years. What happens now if I enter data that is not available? Typically, when I enter, for example, let me say I enter my name, I guess we will get an error message. Why? Because OSV, Orchestrated Service Virtualization, forwards the request to the real system. This is how we have configured it by activating the forwarding, in case that there is no virtualization available. But we can choose. We can define it also in a different way. What would happen if I enter Josef Schmidt, for example? You would expect the same now as for my name. Why? Because there is no virtualization for Josef Schmidt, right? So if I enter now Josef Schmidt, you would assume there must be an error. But there's no forwarding. And why is that? Because we have here in the search a so-called pattern. We have used, I have used different fields for the request and for the responses. And for the search, I am using wildcards. This is what we call pattern matching. This pattern matching enables you and makes testing and service utilization easier. You do not need to copy all, let's say, 8 million records from a CM system. You just define first the test cases and the variants. And based on the variants, then you can define here the pattern matching. So you have, let's assume, 24 variants that you need for test execution. So you will use the last name and an A wildcard and B wildcard and C wildcard and so on. So this is how you can make sure that not only automated, but also manual exploratory testing will be here populated easily for your test execution. So what have we done? We have used the recording. We have extended the recording with a test case design. The next step is, of course, I explained, we can also set up virtualization from scratch by using service definition files. How does that work? This works via our API scan. In Tosca, we provide an API scan. This API scan is also available as a standalone version, so you can also deploy it to all other machines, to developers. And it's free, it's not licensed, it doesn't need to be licensed. The API scan gives you the possibility here to create API test cases. So, as a first step, I will restart my real service. I can reuse the definition, which I can retrieve from my web service. Typically, the web services provide you the definition file. You could also load it from disk. Both is possible. Here, I will now load the sample CRM service, which is our get customer example. API scan here creates a synthetic request and a synthetic response. I can enter again a MOOC Mustermann, which we know that we should get some data. Press the send button and execute the API test case. Now I import this as an OSV scenario, and once it's imported, I can see now that here a module for the request and response has been created and a scenario in the exact way as we have used it as we got it via recording. So no matter if you use the API scan or if you use recording, once you have imported in Tosca, you have the modules and the scenarios. And this is where your starting point, where you then can create more scenarios combined with test case design or also with other possibilities. Of course, we can also create API test cases. So how does that work? Let me give you an example of a Swagger word. Swagger, what is Swagger? Typically, more and more touchpoints applications, mobile applications are created with REST-JSON and are defined, for example, with Swagger. We have here such an example, which is called Demo Coffee Shop. This Demo Coffee Shop first will execute an authorization call, and then secondly, it will use the authorization information to get some information about these coffees. So how can I create now an API test case in Tosca? The first thing is I will use here the definition link, and we'll reuse those definition link here in the API scan. Paste it in the resource identifier, and Tosca, the API scan, creates again synthetic request responses. The authorization example here, request needs data, username and password. So let me enter my username and let me enter my secure password, which is hopefully not your password in your area. Press the send button, and I get a token here. So next step, I will use the token. Still here now, I will do it manually, but of course in Tosca we will then make it more efficient and use the so-called buffers. And then I will choose one of the get functions, where I have now an empty payload, but parameters. Why is that? This is typical for REST-JSON calls. Let me here go back, let me here again show you the get function for the API for the coffees, where we get some coffee information. Here we have a parameter for ID and authorization, and then we get the response, which is shown here. So the ID, I know that this is year 1, and I need to copy, paste here the value from the token, and I need a barrier as a description, what is the kind of authorization. Press the send button, and this is now what I get as the payload. So next step, I select both messages, press API test case, and now this will be imported as an API test case. What is new now, and this is also the same principle that we will have in the next version, in one of the next versions for service utilization. We have here now the technical information, the technical view for the requests and responses in Tosca, where you can see the XML or the JSON file and choose the fields that you want to use for test execution. On the module, automatically the fields are not populated anymore, because typically when it comes to service API test cases, you do not need all of them, but you choose the ones you want to use. So here I choose, for example, the ID and the name, and for the authorization I choose the username and password, and you can see now that these fields are here populated. And for the token, I will use only the token, because this is what I want to reuse. My test case now looks pretty simple. I have, in the same way as provided here for UI test cases, here my coffee get example and the outpost example. I want to use both in one test step, so I just simply drag and drop this here. I can delete this here. Choose that first the authorization has to be done, and then at the end the coffee information should be triggered. Now you can see here a simple view, a view that is readable also from non-technical guys. I can choose here the data that's already provided, because in the modules we retrieve the information from test execution, which could be the data, or which could be something like from a WSDL file enumerations information. Choose here the password. Choose to buffer the token. Buffer, this is in Tosca the way how we store values. I give it a value name token. And then I will here trigger the ID. And here I will choose to use barrier. And then I will use the buffer, which is called token. This is how I first execute the API, the authorization with my username and with my secure password. Then I buffer the token. I will then again execute an API test with one and with barrier token, where we use the token from before. And the next step is to verify the data. Tosca here knows or recommends for a request to insert the data and for responses to verify. It makes sense because typically you verify the response. And this is already our first API test case that I can now run in the Scratchbook. So it will first trigger an authorization call with my name, a.more, and my secure 123456 password. Retrieve a token, reuse the token for the second call, and trigger the calls. And in our example, we can see everything went fine. The same principle will also be used for service virtualization. So coming up with one of the next versions, 10.3, 10.4, you will also see those view on service virtualization. Right before I said we want to combine test automation. We want to fully enable test automation. Till now it was a very manual execution. We execute manually some Max Mustermann and some Volkswagen and BMW. But of course we want to have full test automation. So how can this work? I have already created a UI test case, the modules for each page, and a full UI test case which will trigger the test execution. What I can do now, or what is the recommendation here? In a stable environment, so one of your latest stable test environments, you can now use the recording function. I will here delete all the scenarios, start the recording again, close the browser, and start the test execution. This test case here now will open my browser. It will execute the full UI test case, and as my backend services are available, of course, in my stable test environment, pre-production, for example, it will be able to run. Now, on the first page, the Volkswagen is chosen. On the second page, the insurance data. On the third page, it will trigger the rating and the price option, and so on. Then the quote is filled in. Now, when we press the send button, a new order is created. We buffer this, we so-called buffer the order ID. We will here switch to the order overview, enter this ID in the search areas, choose for the record that we have just added, and go to the state and change it from create to pending or to cancel. So our UI test case, of course, could run smoothly because our backend system was stable. But we typically know that those backend systems are not always stable. So we want to use the recording now to enable our UI test case running without the backend services. In OSV, we can see now there's a lot of services which have been recorded for the whole test case. I will now switch to Tosca and choose here the function input recorded messages, a single scenario. Single is a stateful scenario. This is a scenario where the services depends on each other. For example, you modify data, you add a new record, and then you reload it. This is a stateful, and our test case is stateful, our processes. Again, I'm asked if I want to delete the messages in the background. No, I don't want to. And I have now all the modules on the scenario created in Tosca. In the so-called sequence flow diagram, I can see exactly what happened in the background. So my system test as a first triggered the web service, the vehicle service request, and then it got the information for the vehicle. Then the get customer, then the rating, then the save customer, and several other services. And this area is not only viewable, we can also change here the state. We can change the order or modify here the execution. Next step, I will create a stateful scenario. This is where I use a customized function which is called identify session identifier to set the green buffer. What the green buffer is, we can explain in a technical session or training session. This would be a bit too long for this session now. But after I have run the settings, I can now deploy my scenario back to OSV. In OSV, Then I will have here one scenario expecting all those services. This means I can now shut down all the backend services. Shut down the backend services, go back to the UI test case, and run the UI test case again against our system and test, against our insurance application, without any backend service. So what we have here solved now, what we have done is, we have recorded the messages that were exchanged in the background between the system and test and our 4 different third-party services. We have recorded them all. We have transformed them to a service virtualization scenario, to a stateful scenario. Here, all the services are executed. Even the adding of a record, we buffer the ID. We choose here switch to an auto overview, which is now not only a SID but an end-to-end test case. We will enter here the ID in the search button, and we will again retrieve the data for the added record and change the state here from pending to created or to cancelled. So we have executed, we have solved, we enabled the very first time a full system integration or end-to-end test case without any backend service. This is how service virtualization helps you to, in the future, to create and execute your full test cases and embed it in a CI or even for your HR teams. This is one test case. Let me just give you an outlook. Of course, we cannot only execute one test case, we can execute a full regression portfolio. So what I have done here is I have set up a test case design with 15 examples, different variants, different cars, different horsepower, different insurance, persons, different ages, and so on. And of course, using functions for the date of birth or for the random, for the order ID. On the service virtualization side, I have converted the recording into a template. It's the same principle I have done in the very first second with the get customer. And I've also used something what we call buffer. So I have showed you the buffer before, so we store the order ID and reuse it then later in a get order ID function. And the same thing I have done on the UI part. On the UI part, meaning that I use the same data for test execution from the UI, which makes sure that I execute on the one side data or triggered with data against the system and test, Max Mustermann, Jon Snow, and in the backend for the services, of course, service virtualization knows Jon Snow and Max Mustermann because I'm using the identical data. So I just simply need to upload those examples. I just need to upload those examples now to OSV, which is here the function deploy to scenario. Deploy those 15 scenarios. In the back end, there's a short, what is called sanity check running. The sanity check enables here, or checks if everything is right, if the data is right, and if the service port is set, and things like this. And once the sanity check is done, those scenarios are uploaded to OSV. In OSV, in Orchestrated Service Virtualization, I will delete the one scenario that we've created now, and I have here now my 15 examples. On the UI part, I have also already created the instances, and will run those instances in Scratchbook. What I'm now executing is not just one test case, I'm executing a full smoke or regression portfolio without any third-party service. This is how you can, in the future, enable and make sure that your systems under test are fully tested on a level UI or API system and system integration test without any third-party system. Again, the first test case will run, the second will run, so we see we can successfully test our system under test. Each test case takes about 50 seconds. Multiplied with 15, we will not wait for the result. This would be just 10 minutes watching. But I want to show you something else. Now in the background, the second test case is already running. I will here pause it, and I want to show you the completed area. The completed area in OSV shows you the scenarios that have been completed, and you can see here a red sign. What is that? OSV verifies, this is what I said in the beginning, at interface level. So it checks if all the data has been handed over correct from the system on a test to typically third-party system or here to service virtualization. In scenario detail, I can see here now that the street address, that there's something wrong. It has a different value. So what was wrong here? I can identify here already at an earlier stage that my system under test has a defect, and that this defect is something like the mapping from the input data to the web service. Even near to developer in my HR teams without having deployed the system to a test environment. And this this leads us to a short explanation how should service virtualization be used. Typically, when we show the principles of service virtualization, the question of our customers is, or the idea is, where can we use service virtualization? Typically, when you do, or when you use to do the testing in the test environments, the first information, the first answer is, let's use service virtualization in the integration environment, because this is where we have problems with our other systems. Yes, it's right, as a first step. But on the long run, we would recommend to do it in a better way. Why? Service virtualization in an integration environment is helpful as a first step. It's helpful to do recording and to understand your systems and what the systems are exchanging and the services. But on the long run, you still need to have something like a switch. You need to be sure what I'm testing against. Am I testing against the real system or against the service virtualization? And you just simulate some of those services typically, which are typically unstable or third-party services that are expensive. But what you never may forget is you still do all your tests on the end-to-end level. So if I use service virtualization in my integration environment, I still rely on the so-called inverted test pyramid. All my tests are executed end-to-end, basically on the UI. I just fix those systems which prevents me from executing those tests. So ask yourself, how often can you deploy to an end-to-end test environment? And how long does feedback loops take if you test in an environment? How many teams are involved to get your systems to the test environment, to have a workable test environment? And how long does it take to identify a defect? And how can be continuous integration implemented? This leads us to the recommendation that there's a better approach for service virtualization. First step, yes, use it in your test environment. But there's a second step. And the second step is a shift-left approach. This is what HR teams, what DevOps is standing for. Near to development, in the HL teams, where testers should cooperate with those teams. No matter if it's a modern system or if it's a legacy application. This could be HTML5 application, this could be also SAP, the Delphi, Win32, a Java application. Based, or let's say near to those teams, you will here create service virtualization, focusing on your system under test, simulating all surrounding systems, executing unit tests and executing UI and API tests, triggered via, hopefully, a continuous integration server. Tosca executes and have here the possibility to integrate to the 3i server, executes UI and API tests, and OSV, Orchestrated Service Virtualization, simulates all surrounding systems. The big benefit is you will not do this only for the modern HTML system, but also for those systems which could be legacy systems or system of records if they require third-party systems. The big benefit is that you reduce your feedback loops, you reduce the effort. Near to development teams, when you cooperate here as a tester, you have immediate and quick quality feedback. You can integrate it in a CI pipeline, execute those tests every day, every night, or every time your developer checks in. And later, when you have executed the test and when you have got a huge or a good quality feedback, then you will deploy the systems to an end-to-end environment and reuse those artifacts, the test artifacts that the teams in the HL teams has already created in your end-to-end environment. So that's how we recommend and how we transform testing in the future. I thank you for listening, and I hope we have time for questions.
Okay, Alexander, an amazing presentation. Thank you very much. There was an awful lot in there, and there are a lot of people who've asked a lot of really, really good questions. Some very highly technical ones as well, which we might not have time for, but we can always go to support for those. But there are a few which have come in, which I'd like to ask you now. One of the first ones, we had a number of questions around what can be used, which technologies can be used for OSV and testing. In particular, we got asked about Java, SAP, iDocs. Are all of these compatible with OSV and Tosca, or not yet?
Okay. So we currently support XML, we support JSON, we support as formats. We support here as transport on a transport layer, file, web services, ESP like ESP via queuing system, which is typically GMS, like RabbitMQ or TipCompQ or ActiveMQ or WebSphere. SAP, we support SAP S4HANA, we support OData for S4HANA. We are working, or we have on the roadmap RFC and IDOC. We do not support it as of now, but we have it on a roadmap. So please come to us. Let's align here with our product management, discuss if you could be included in a beta program, to see and to understand your needs for RFC or IDOC, and so we can support it then. Java service classes, we do not support it as of now. It's also on the roadmap. Same answer here, please. Let's align here and see if we can include you here in a better program.
Okay, perfect. Thank you very much. Another question, just a brief one. This one's easy. What Tosca version is supported by OSV? And do you need any special licenses?
Okay, so Tosca versions. Recommendable is of course the current version. So current version is 10.2. You could also have 10.1 or 10.0, but we of course recommend 10.2 because then you have all the new features in there. Typically, there's also always a parallel version, Tosca and for service virtualization. Yes, it's a separate license. It's an add-on license. The license is concurrent user-based license. So no matter how many services, how many environments you have, only concurrent user-based. Concurrent user is on a designer-based, so on those testers who creates the virtualization, maintains them, you need here an additional license.
Perfect. Thank you very much indeed. Sorry, did I interrupt you?
Yeah, this is the license. Just in short, of course, please come
Yes.
back here to sales and let's discuss that in detail.
Our sales team are always willing to help you, very much so. One last question, and then we've got to get to the closing side. A couple of people asking about the differences about stubbing. So developers are using stubbing. Why is OSV better than using stubs?
Okay. So why is OSV? Why is any kind of service virtualization better than stubs? Let me answer that from two views. The first view is where stubbing used. Stubbing is used currently or mostly from developers, and it's used to enable unit tests. Those unit tests cover typically. Of course, they cover have a test coverage, but not that high test coverage that we want to have, including system and system integration tests. So it's more, here's the one side is the usage. The creation. Stubs are created typically from the client developer, but not let's say verified or provided centrally. So you have a redundant setup. And more important is what do stubs provide? Stubs do not provide combination of test data. They do not provide functions or intelligence behind. They do not provide coverage of test variants. What is a test variant? Imagine you have a checkout in your online shop in a basket, and then you have different variants like credit card and PayPal and all these different kinds. And for credit cards, you have different credit cards, and you have valid, invalid credit cards. You need to test all those variants. Stubs do not provide all those variants. So what is missing for stubs is lacking test data connection, variance, intelligence, and this all leads to a very basic test coverage. Or let me say, stubbing is the root cause of the problems that we have as of now, because stubs are too simple and do not enable a high test coverage.
Perfect. Thank you very much. I'm going to have to say really sorry. As we started on the questions, a whole flood of questions came in, and we simply don't have time to answer them, so I apologize for that. But I tell you what we can do is I will move instantly to the slide which shows you where you can get further information. So I hope that's appearing. So if you need more help, please do contact support@tricentis.com. These guys are there and are able to help you all the time. Really good, amazing team that are really highly skilled at what they need to do and can absolutely answer almost all of your questions. If it's a training issue, please contact us at academy@tricentis.com. We love to hear from people. We love to hear what we can do and how can we help and how we've done. Don't forget that we've also got a knowledge base. This knowledge base on the support site has thousands of articles that more often than not, can answer your questions without even having to make a phone call or text or anything else like that. We, of course, have our online manual. We work very hard to make sure our online manual is up to date and gives you all the information you need. So please take a look at that as well. And of course, we do have a whole series of MOOC recordings that can go back. For example, if you want more information on API tests alone, we have an API test MOOC waiting for you to be watched. Also, bear in mind, we Facebook, we LinkedIn, and we tweet. And all of these will have information, but often have links and other areas where you can find further information. For example, there may well be other webinars available that you could listen to from Alexander that would give you the information that you need or give a more in-depth dive into OSV itself. The last thing before we go, because we are now running out of time, is we do have another MOOC coming up. This is a very exciting one for us. We've had one evangelist join us today. In 2 weeks' time, we have our second evangelist joining us, which will be Ingo Philipp, who will be talking about exploratory testing for Atlassian Jira. This is very exciting, and it's a very interesting MOOC, I'm sure, as they always are from Ingo. So please do join us for that. And please, at the end of this webcast, please do complete feedback. We thrive on your feedback and need to know what's good, what's indifferent, which is obviously nothing, and what other topics you would like us to cover. So on that note, I'd like to thank you all for joining us very much. It was a pleasure to having you. Apologies that we haven't answered all your questions. Thank you most of all to Alexander for joining us, and what was a fascinating MOOC of an incredibly cool product.
Thank you for attending.
And we hope to have you, or speak to you and see you next time for exploratory testing. So thank you very much, and goodbye.